Hello everyone, welcome back to the next video on introduction to the ferrous alloys. In this video, I am explaining about the importance of stainless steel and its microstructure and its classification. Classification, classification, microstructure, and application. Right? So first of all, as we know from the earlier knowledge, stainless steel are more resistant to the corrosion. They are mainly used for the corrosion resistance for the various environmental conditions, for the humid airs or dry air. So there are different, due to the variation in the humidity. There is a various conditions for the environmental conditions. To this, it is resistance. It's a corrosion will take place due to the humid air conditions, variation in the humidity. The stainless steel will resist for it. Why it will be resisting? What is the different property leads to this one? It is because of addition of a alloying element called as a chromium. So we have to add at least of 11% of a chromium in it. So then only we will get a stainless steel. That means corrosion resistance steel. Along with the chromium, we were also adding other alloying elements also to enhance its mechanical properties. And we can also use it for the heat treatment also. By heat treatment also we can get the different mechanical properties as I explained in the previous slides. Okay. These stainless steels are divided into three main bases, main important classes. There is a Martensitic stainless steel, Ferritic stainless steel, Austenitic stainless steel. As the name indicates that the predominant phases. These names will indicate the predominant phases present in the stainless steel. Here the predominant stage is Martensite, here the ferrite, and here it is austenite. We will see one by one in detail. So what is its application? What are the important classes in this one? Okay. First is Martensitic stainless steel. As I explained, the predominant phase is Martensite. Okay. As we know this, Martensite is very tough and a more corrosion resistance. Hence, it has a more wide application. And the by heat treating this Martensitic stainless steel will give us a more applications. The common examples of Martensitic stainless steel are, so I will write the UNS number and its main composition. So main, I will write composition and its application. Okay, so UNA number for Martensitic is S410000. Main composition is 0.15% of carbon, 12.5% of chromium. As I said, it should be greater than 11, and 1% of manganese. Due to addition, due to this combination, can be used in many applications such as rifle barrels, jet engine parts, etc. And one more is S4 4002. The main composition is 0.7% of carbon and 17% of chromium, 0.75% of molybdenum, due to which the brittleness is increased and its hardness is also increased, and 1% of manganese. This is the chromium has been increased from 12.5% to 17%, and the carbon is also increased, and we were adding the one more important element called as a molybdenum, that is 0.7%. Due to this, its hardness is more than this previous one. As we know that the addition of the carbon will enhances the property as well as hardness of the material. So due to which it is commonly used in the surgical tools. Okay, so as we know that the surgical tool should be more corrosion resistant, they are exposed to the different kinds of a liquid such as blood, water, and they are dipped in the water and the water for longer duration of time. If there is a small corrosion also on a surgical instrument, it may harms to the patients. To 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 making a concern about these things, we have to care about corrosion resistance. We have to take of the corrosion resistance elements in the surgical instruments, and these materials can also be used in the implantation of the bones. For example, nowadays it has been changed to stainless steel to titanium based alloys. They use it for titanium based alloys, but in previous decades these steels, Martensitic stainless steels, when used in the implantations. So this is all about the Martensitic stainless steel. So next topic is Ferritic as well as the Austenitic stainless steel. So Austenitic stainless steel, as the name indicates, the predominant phase is austenite. As we know that this is a FCC structure, austenite is FCC structure, it can consume more amount of chromium. So more amount of carbon as well as chromium. So hence we are adding more amount of chromium here compared to that of the Martensitic stainless steel. Being more amount of chromium, due to which it's more corrosion resistance than compared to that of the Martensitic. But the strength, when we compare it to the strength as well as the strength, the Austenitic are lesser, little bit lesser than that of the Martensitic. But we can't heat treat both ferritic stainless steel and Austenitic stainless steel because they are very soft in nature. They cannot be heat treatable. The strength can be enhanced with the help of cold work. Cold work can enhance strength of both ferrite and austenitic stainless steel. Okay. And due to this most corrosion resistance property, resistance property, they are most they are produced, this can be produced in larger quantity. Okay, so most common example of austenitic stainless steel is UNS number, this is composition, and here it is application. UNS number is S30400. The composition is very less quantity of carbon, but 19% of chromium we are adding, 9% of nickel, and 2% of manganese. And these can be used in cryogenic vessels, chemical and the food processing equipments. I will write it in short form. I require some space to explain other example also. One more example is S31603. Main ingredient is very less quantity of carbon added, but 17% of chromium is added, 12% of nickel is added, 2.5% of molybdenum, and 2% of manganese. And the main application is welding constructions. Constructions. See, so one most important difference between the previous austenitic stainless steel and the Martensitic stainless steel and the austenitic stainless steel is chromium is increased first thing, and the one more alloying element is added, nickel. Due to the addition of nickel and the chromium, it has been given the outstanding performance in the corrosion resistance. Okay, this is the main commonly used and the mostly produced largest producing stainless steel. Last but not least, that is ferritic stainless steel. Steel. It is having BCC structure and the predominant phase is microstructure is alpha ferrite. Okay, and as I explained in the previous slide, the strength can be enhanced with the help of a cold work, not by heat treating. The common example are S40900 and the composition is 0.08% of carbon, 9% of chromium, very less quantity, and the 1% of Mn, manganese, 0.5% of nickel, and 0.75, one more a new element is been added, which is a main key factor for increasing the strength of this ferritic stainless steel is 0.5% of titanium. Hence, due to this, it is a more ductile and malleable and corrosion resistance. When we are compared to the plain carbon steel, it is having only the malleable and ductile. But here, the ferritic stainless steel is little bit harder, increase in the strength, corrosion resistance, and they can be used. It's a little bit ductile. So because of this one, they can be used in the agricultural space, automotive exhaust components, and tanks, etc. And second one is S4 4600 and 0.20% of carbon, 25% of chromium has been added here, and the 1.5% of Mn. They can be used in the valves, glass molds, etc. Okay, the more percentage of carbon chromium is being added. This is all about the stainless steel. As I have mentioned with on some figure, it can be used applications that is used in agriculture, construction, automobiles, the tanks and other things, power generator, 3D printers, airports, fire alarms, chemical and the processing equipments, etc. It has been used from agricultural department to agri to aerospace industry. The stainless steel has been used. Because of this addition of this is a additional property, corrosion resistance property, and there is a strength has been increased with the addition of an alloying element. They can be used in the wide range of applications from agricultural industry to the aerospace industries. Thank you.